Hello everyone, welcome back to my channel. Now in the series of MCQs on analog electronics, we'll be starting off with some questions. So the first question is, the feedback factor of Wien bridge oscillator using op-amp is? So the answer is, it is half, because at the resonant frequency R2 by R1 of Wien bridge is half. So the gain of the amplifier must be greater than 2 to maintain sustained oscillations. Moving on to the next question. For the audio frequency applications, the popular oscillator used is? Answer is A, that is Wien bridge oscillator. Why? Because it has ease of tuning, it has very low distortion and a good frequency stability. So it is very popular for audio frequency applications. Next, the Colpitts oscillator is also called as, it is also known as tank oscillator, LC oscillator, resonant circuit oscillator. So the answer will be D, that is all of the above. Next, a quartz crystal oscillator consists of, option is C, that is both series and parallel frequencies. Why? Because we know that crystal oscillator has two equally spaced and closely spaced resonant frequencies. In crystal oscillator, the series resonant frequency occurs when the reactance of the capacitor is equal to reactance of the inductor. So the parallel resonant frequency occurs when the reactance C2 is equal to the reactance of RLC1 branch. So the answer will be C, that is both series and parallel frequencies. Next, which oscillator are easy to fabricate in a monolithic IC? So the answer is D, that is relaxation oscillator, because we do not use inductor and its output depend only on the non-linear characteristic of the circuit. Therefore, relaxation oscillator is used as monolithic ICs. Next question. Which of the following is not, say it is not a sine oscillator? So the answer is C, that is relaxation oscillator. Basically, it is a non-sine oscillator which is used to generate square, triangular or pulse waveforms, and all of the other are the sine output waveform generators. Next, voltage control oscillator are used commonly in phase modulators, frequency modulators and phase clock loops. So the answer is D, it is used in all of the above. It is used in electronic jamming equipment, frequency generator for the production of different types of noise, phase log loops, and frequency synchronizers. Next, one of the following is primary function of an oscillator. So the primary function of oscillator is to generate sustained oscillation at constant amplitude and specific frequency. So the answer is C. Next, which oscillator are easy to fabricate in monolithic IC? So the answer is D, that is both B and C, triangular wave and sawtooth wave. Both can be employed to generate both triangular and sawtooth waveforms. Next, feedback circuit in an oscillator can be accomplished by any one or the combination of the above methods, that is D. So we can use resistive coupling between input and output, we can use capacitive coupling, or say we can use the inductive coupling as well. So oscillators can be built with different feedback circuits to produce proper phase and amplitude. So these types of oscillator include RC and LC oscillators. Necessary requirements of an oscillator. So the answer is both A and B, that is D. Amplitude stability and frequency stability are primary requirements of the oscillator, which determines the ability to maintain a constant amplitude, sustain oscillations and desired frequency at the output waveform. Next, The Barkhausen criteria for an oscillator is loop gain should be unity and loop gain should be less than unity. Then we have the phase of a feedback signal with respect to input should be 0 degree or 360 degrees. So the answer is that loop gain should be unity and the phase of the feedback signal with respect to input should be 0 or 360 degrees. So the answer is D, that is both A and C are the requirements of Barkhausen criteria. Next, LC oscillators are used for the production of waveform with frequency ranging from 1 MHz to 500 MHz. It is also known as RF or the radio frequency oscillator. Then next, which of the following oscillators are used for low frequency applications? So RC oscillators are used for low frequency applications because it is difficult to be realized. LC is difficult to be realized at low frequency size. So size of the inductor required is very large, expensive and bulky. Oscillations of a RC phase shift oscillator is, so the answer is 1 by 2 pi RC under root 6. So this is the frequency and the feedback factor is 29. Next, a diode has two terminals. The P terminal is known as anode. So a diode is a semiconductor device which is formed by combining p-type and n-type material to diffuse together. So p-type has holes and n-type has electrons. So p side is the anode and the n side is the cathode. Next, a working diode must have low resistance when forward biased while high resistance when reverse biased. So working diode means that the diode is biased or connected with a DC source. When a diode is forward biased, that is positive terminal is to anode and negative to cathode, it provides a low resistance path because it helps the majority carrier to cross over the barrier potential and conduct the flow of current. When a diode is reversed bias, it provides a high resistance path because majority carriers are which are flown away from the junction and no current conduction can take place. So the answer is B, that is should be low resistance when forward biased and high resistance when reverse biased. Next, electrons in an p-type material of a semiconductor are called as minority carriers. So electrons in p-type and n-type of a semiconductor are called minority carriers and majority carriers respectively. Electrons are less in number in p-type as compared to holes present in it. So they are minority carriers in p-type material. Next, silicon and germanium are tetravalent because they belong to group 4 of periodic table consisting of 4 electrons in their valence shell, and we can also define carbon, silicon, germanium, tin, lead as the fourth group elements. Next, a diode, that is P-Njunction, when reverse biased act as a off switch. Why? Because at the reverse bias, the positive terminal of the battery is connected to the cathode and negatives to the anode. So it does not conduct any considerable electric current and hence act as a switch off circuit. So this was all about this topic. Thank you.